Hello, in this video we will talk about hypergeometric random variable. So first we take a look at an example. A bin contains n plus m batteries, and of which n are of acceptable quality and m are defective. So there are total n plus n batteries, and n are good and m are not good. And a sample of size small alphabet, lower alphabet n is to be randomly chosen, so without replacement, in the sense that the set of sampled batteries is equally likely to be any of n plus m n combinations subsets of size n. So this means if we choose n items from these n plus n items, they are in total n plus n combinations different ways, right? And if we let x denote the number of acceptable batteries, so x is acceptable batteries from n, right? N batteries in a sample, then any random variable x whose probability mass functions is given by the following equation. This equation is said to be a hypergeometric random variable with parameters n, m, n. So we just say again, there are total n plus n batteries, and we choose n from them, and we are interested in the probability of x, where x is acceptable quality, or to say good items from n, right? So x can be from 0 to 1 to the minimum of n and n. So this probability is calculated by a division where denominator is the total different ways of combinations n plus n with n. And the numerator is the production of I, where is equals x here, the positive, or say the acceptable items from n, and n minus I, which is the defective items from n. So this probability calculated as follows, and we say this random variable follows hypergeometric distribution, and this is a hypergeometric random variable x. So next we look at an example to make calculations for hypergeometric random variables distribution. And the components of a 6-component systems are to be randomly chosen from a bin of 20 used components. So we choose 6 from total 20, and the resulting system will be functional if at least 4 of its 6 components are in working condition. So which means if at least 4 of these 6 components are good items, then we are satisfied with the function. And if in these total 20 components, there are 15 are good components and 5 are not good components, so now what is the probability that the resulting system will be functional? So it is quite clear that this is a hypergeometric random variable problem, and follows the parameters as 15, 5, 6. So 15 good items and 5 bad items, in total 20, and we will choose 6 from them. And we are interested in the number of good items in these 6. So if these good items, the number larger or equal than 4, then we are satisfied. So we will calculate the probability of x larger or equal to 4 from this hypergeometric distribution. And equation and calculation is quite clear. We just make a summation from I equals 4 to 6 for this probability. So this is for the 4, this is for the 5, and this is for the 6 good items selected from in total 20. So the numerator is 26 and the denominator is 26 combination, and numerator is 3 items summation, and each is the projection of 2 combinations. So 15, 4, 5, 2, and 15, 5, 5, 1, and 15, 6, and 5, 1. So the final result is about 0.8687. So if you are not knowing very well for the combination calculations, we just make a simple case. For example, 26 equals 20 factorial divided by 6 factorial and divided by 20 minus 6, which is 14 factorial. So for example, for this one, 15 4 combinations, which equals 15 factorial divided by 11 factorial and divided by 4 factorial. And this one is 5 factorial, which is the projection from 1 to 5, right? Divided by 2 factorial, which is 1 times 2, and divided by 3 factorial, which is 1 times 2 times 3. Thanks for watching.